So the question is, find an equation for the plane that passes through the point 2, 3, negative 4 and is perpendicular to the line L equals 0, 6, 3 plus t 1, negative 2, 3. So let us write down what we know. This is what I like to start off with because it makes it easier for me to visualize. So the plane, let's call it H, passes through the point, let's call it point P, 2, 3, negative 4. Secondly, we know that the plane H is perpendicular to the line L of t is equal to, I'm writing it in vector form, parameterized form, 0, negative 3, negative 6, 3, plus t, 1, 2, negative 2, 3. So this is what we know, and to better visualize it, I'm just going to draw it out. So this is the plane H. This is the line L, which is perpendicular to the plane. And this is the point P, somewhere on the plane. So line is perpendicular to the plane and P is on the plane somewhere. Alright, now that we can visualize this, let's get to solving the question. Notice that the line is perpendicular to the plane, but the plane also has a normal vector. The normal vector is a vector that is simply perpendicular to the plane and sticks out. So, because the normal vector is perpendicular to the plane and the line is also perpendicular to the plane, the normal vector of H is pointing in the same direction of the line L of t. There is the normal vector, and you can see here that they're both perpendicular to the plane H. So because of that, normal vector, I denote it as n with a little arrow on top. So because of that, the normal vector n is equal to the direction vector of the line L of t, because they're pointing and going in the same direction, which is 1, negative 2, 3. Okay, that's the first part that we should notice. Now recall that the plane equation can be made from the dot product and setting that equal to 0. So let us denote a point called Q, which has coordinates A, B, C. And so the vector between Q and P is QP. So QP, I'm going to dot that with the normal vector to make the plane equation. So let us do the dot product. So the normal vector is 1, and then we take the first coordinate of QP. So let me just write down QP for you. So QP, well actually I'm going to write PQ, final minus initial, but don't worry about that. It doesn't really matter if you do QP or PQ. Here I know A minus 2, B minus 3, C plus 4, and 2, 3, negative 4 comes from the question itself, 0.2, negative 4. So let us compute the dot product. After that, we just simplify, distribute the terms, do some basic algebra. Then we get A minus 2B plus 3C equals negative 16. And ABC are just variables. So we can also call ABC x, y, z. So I'm just writing that down. X minus 2y plus 3z equals negative 16. And that is our plane.